Okay, we'll start a new topic. Electricity and chemistry is done. Rate or speed of the reaction. So how we define an average rate or speed of the reaction? Average rate or speed of a reaction is time taken by reactant to form product. So how much time the reactant will take to form a product, that's called the speed or the rate of reaction. And there are two ways to calculate the speed or the rate of reaction. The formulas, there are many ways to calculate, but the two formulas which you will learn to calculate the rate. So rate of a reaction is change in amount of reactant divided by time interval. Or there's another formula to calculate the rate is change in amount of product divided by time interval. So both formulas can be used to calculate the rate or the speed of a chemical reaction. So example, the amount of reactant always decrease when a chemical reaction occur, and amount of product always increase because the product is the substance which is formed and the reactant is the substance which used up during a chemical reaction. So if there's a table given, and you want to calculate the rate or the speed of the reaction, the first table you have reactant, time, and rate. And in the second table, you have product, time, and rate or speed of a reaction. So we carry out a chemical reaction and we record the amount of reactant at different time intervals. So time zero means the beginning of a reaction. After every 2 seconds, we measure the amount of reactant. So in the beginning example, we were having 40 grams of reactant. The reactant was in gram and the time was in seconds. Then after 2 seconds or 2 minutes, because here in the second, so example, after 2 seconds, we are left with 20 gram of reactant. After 4 seconds, we are left with 15 grams of a reactant. We are left with 13 grams of reactant and 13 grams of reactant. If a question is the first value, because that's the beginning of a reaction, so you cannot identify the rate. From you will start with the second value because the formula is change in amount of reactant divided by time interval. So what will be the rate here? So initially you was having 40, you have 40 grams of reactant, then you have 20 grams. So how much is a change in the amount of reactant? So that's change is 40 minus 20, that's equal to 20. And 20 divided by 2. So what I will get? I will get 10 gram per second. Is it clear? Like I have 40 grams. After 2 seconds, I'm left with 20 grams. So how much is the change? The change is 20. And what is the time interval? It took 2 seconds for that change. So that's why 20 divided by 2. So rate at 2 seconds is 10 gram per second, means that 10 gram of a reactant is changing into product every second. Then it is 20, it changes into 15. What is the rate here? So the change is 5 and the time interval is 2. So 5 divided by 2, that's equal to 2.5 gram per second. Then it is 15, changes to 13. What is the rate here? So change is 2 and the time interval is also 2. So 2 divided by 2 is 1 gram per second. Then it is 13 and it remains 13. So the change is 0 and 0 divided by 2. So you will get 0 gram per second. When the rate is 0, it shows that the reaction stops. So in the beginning, you can see the rate is faster, but with the passage of a time, the rate is decreasing. What is the reason why the rate or the speed of the reaction was decreasing? Because in the beginning, you have more particles. And there's a particle theory. The particle theory explains that if there are more collisions, more effective collision between the particles, then more likely they will react and form the product. So in the beginning, you was having greater amount of particles. So as you have greater amount of particles, more likely they will collide with each other and form the product. That is why in the beginning, the speed of the reaction was fast. But as with the passage of a time, the amount of a reactant is decreasing. So as the amount of reactant is decreasing, it shows that the number of the effective collision between the particles will decrease. If a number of effective collision will decrease, the rate of the reaction will also decrease. So if I sketch a graph to show my result, this table. So on x-axis, I take time. On y-axis, I will take amount of reactant. So you have more reactant in the beginning, the start of the reaction, greater amount of reactant. But with the passage of the time, the amount of reactant is decreasing and eventually there is no change. So what it shows that the reaction stopped. Which position the reaction is fast? In the beginning, the reaction is fast, then the reaction slow down, and then the reaction stop. Is it clear, this graph? If you have reactant in time, in the beginning, you have more particles of the reactant. That's why they have more often collision, which result in a formation of greater amount of product or greater change in amount of reactant to product. But with the passage of a time, amount of reactant decreases, so less collision between the particles. That's why the reaction slow down. And eventually the reaction stops, which shows that there's no change in reactant. And how we identify, basically the slope here represent the rate of the reaction. So in the beginning, it is steeper, it shows the faster reaction. Then the slope is decreasing, means the rate is decreasing. Then horizontal line means slope is 0, so rate is also 0. How to draw a graph is from the values, because you can see here in the beginning I have 40 grams of reactant. then I have 20 grams of reactant, then I have 15 grams of reactant, and then 13 grams of reactant. So when I mark these points, like when time is equals to 0, I was having 40 gram of reactant. When time is equals to 2, I have 20 grams of reactant. When time is equals to 4, I have 15 grams of reactant. When time is equals to 6, I have 13 gram of reactant. And time is equals to 8, I have 13 gram. So when I plot these points, join these points, I will get the curve, and this curve in the beginning it is steeper, but the slope will decrease, which shows that the rate of a reaction decreases. But if you sketch a graph for amount of product and time, or if you have a table in which a product amount is given, say volume of the product is given. In the beginning, the time interval, every 2 seconds you're recording the rate, or every 2 seconds you're recording the amount or volume of a product. So in the beginning you have 30, then it is 50, then it is 55, and then 55. So if I say what is the rate, volume is in centimeter cube, and time example in second. So in the beginning it is 0, it becomes 30. So what is the change in amount of product? That's 30 divided by time interval, how much time it was taking to form a product? 2 seconds. So 30 divided by 2. So change was 30 and time interval was 2. 30 divided by 2, that's equal to 15 centimeter cube per second. So the unit of the rate is not constant. It depends on what is the unit for the reactant and what is the unit for time. Like example, if reactants are or reactant or product, example in this I took a product in centimeter cube, so that's why it is centimeter cube per second. So sometime they ask state the unit of the rate. So you have to check a question. According to the question, the unit of the rate will vary. It is 30 become 50. So what is the change here? It's 20. And the time interval changes from 2 to 4. So that's equal to 2. So the rate is equals to 10 centimeter cube per second. It is 50 become 55. So 50 become 55. So that's equal to 5 divided by 2, which is equals to 2.5 centimeter cube per second. And 55 remain 55, no change. So change is 0. So 0 divided by 2, I will get 0 gram per, centimeter cube per second. So what it shows, when the rate is 0, it means the reaction stops. And if I sketch this result on a graph, volume of the product and time. So this will start with 0 because when the time is 0, the product is 0. Then example this 30, then 50, and 55. So after 2 seconds, it is 30. After 4 seconds, it is 50. After, this was the first point. After 6 seconds, it is 55. After 8 seconds, it is also 55. So when I join these points, I will get a curve which is steeper in the beginning, but with the passage of a time, the slope decreases. So slope here represents the rate of the chemical reaction. In the beginning, the reaction is fast, but here the reaction slow down, and at this time the reaction stops. And again, If they ask what is the reason why the initial rate is faster, initial rate, it depends on the question, the unit. If reactant they give you in gram, you will take in gram. It depends on the question, like the table which is given to you. So why the reaction is faster in the beginning, it's the same answer, or why initial rate is faster. So reason why the initial rate is faster, because greater number of particles at the start of reaction, so more effective collisions. So as we have greater number of particles in the start of reaction, they have more effective collision, which result in formation of greater product in the beginning. So product is formed by a react when the reactant particles collide. So greater the number of reactant particles, greater the rate or of a chemical reaction. Is it clear? Any doubt in this? Take the screenshot. I'll move on to next part. Uh, 1 minute left. So in the next session, which I link I share with you, I will explain, continue the topic. So the idea of rate of the reaction is the collision theory. So collision theory state the rate is proportional to number of effective collisions. Means if there are more collisions, the rate of the reaction increase. So if I have only say 3 particles, or for example 5 particles, number of the collision will be smaller. But if I have greater number of the particles, if I increase the number of the particles, so what will happen? More likely they will collide, and as more likely they will collide, they will it will result in a formation of a